All right, let's go ahead and take a look at the multiple choice part here, the paper 1 problems. So which of the following is a fundamental unit in the system in SI? Amperes. Memorize. Now here we want to get the estimate of the resultant force. So notice we're going to have one component going this way and this component going the other way. And so what we realize is that when we combine the vertical component, the resultant vertical part, if I combine 1 and 2 here, is I'll get something a bit shorter, 1 and 2 together. So when we actually estimate this, this is these two things added together should give us a resultant force that's, well, 1500 is a little bit too big. We're not going to get 0, we're not going to get 2000. That's if they either are completely against each other or completely lined up. It's really a choice between B and C, and when we actually eyeball this here and we look at the resultant vector, we treat this like a hypotenuse here. That's about 1000 when we eyeball it. And for number 3, an object is subject to air resistance, and we want to know what would give us a straight line graph. Now, S versus, well, let's look at our equations. We have V squared is V naught is U squared plus 2AS. And let's be clear, that's 0 if we start from rest. So V squared is 2 times A times S. And this is equal to F over M. So if we've got a constant force, we'll get a straight line graph of this is our y and this is our x, so it would be S versus V squared. All right. Now, velocity time graph of an object subject to a constant force. That didn't say constant velocity. Acceleration is the constant force divided by m. So we end up getting a linear graph like this because we have a constant a. All right. Number 5. We're moving at constant velocity and we want to know the net force. I don't care what we think it's doing or how. If the car is moving at constant velocity, the forces combined to give us balanced or 0. And then number 6, we want to know the tension in the connecting rope if we've got these boxes like this. So let's be clear. So I'm going to call this the tension here. We'll draw a free body diagram. We'll call this T and this T. And I'm only going to worry about the horizontal forces. So we have 30 minus T equals 10 times A for the first block. And then T equals 10 times A for the second block. And we can actually go ahead and solve for the tension by substituting. So we have 30 minus 10A equals 10A. So A ends up being 15. And the tension, 1.5. And the tension ends up being 15 newtons. All right. So a woman is standing on a flat section of ground. This is her weight. Newton's third law, the equal and opposite force is not the earth exerting a force. It is not the woman exerting a downward force. It is the fact that the woman actually pulls the earth up with the invisible gravity pull that is equal and opposite to the invisible gravity pull that Earth puts on her. So that's our multiple choice section.